Hello viewers. Welcome to the YouTube channel. In this video we will discuss Class 12 or 2nd PUC Physics Chapter 1, that is Electric Charges and Fields, Class 5. From basic to advanced level. And one short important physics formula class link is in description for board, JEE, KCET and NEET. So watch till end, share with your friends, don't forget to comment, subscribe the channel. In previous class, we studied electric dipole, electric dipole moment, physical significance of dipole, dipole field, expression for the electric field at a point along the axis of dipole, expression for the electric field at a point on the equatorial plane of electric dipole. That video link is given in description, don't miss it. Support and subscribe. Today, starts with physical significance of dipoles. Let's start. Physical significance of dipoles. 1. Most of the molecules have zero dipole moment. 2. However, they develop dipole moment when they are placed in an external electric field. But some molecules there is permanent electric dipole moment even in the absence of electric field. 3. The substance having this type of molecules are used in important applications in the presence or absence of external electric field. Note: dipole in uniform electric field. When an electric dipole is placed in uniform electric field, net force on the dipole is zero. When an electric dipole is placed in non-uniform electric field, net force on the dipole is not zero. A torque acts on the dipole placed in a uniform or non-uniform electric field till dipole is completely aligned along the direction of electric field. Next, expression for the torque, couple, acting on an electric dipole placed in a uniform electric field. From the figure, consider an electric dipole placed in a uniform electric field, E. Let plus Q and minus Q are two charges of dipole. P is dipole moment acting from minus Q to plus Q. 2A is distance between two charges. Theta is angle between the directions of E and P. Therefore, force acting on plus Q is F is equal to QE along E. Force acting on minus Q is F is equal to minus QE, opposite to E. These two forces, that is F plus Q and F minus Q, are two equal and opposite force acting on the dipole. As a result, torque is acting on the dipole. Therefore, torque is equal to magnitude of either force into perpendicular distance. That is, τ is equal to EQ into BO. Mark it as equation number 1. To find BO, from triangle BOA, sin theta is equal to BO by AB. Therefore, BO is equal to AB sin theta. But AB is equal to 2A. Therefore, BO is equal to 2A sin theta. Mark it as equation number 2. Now, substitute equation 2 in equation 1. We get τ is equal to EQ into BO. That is, τ is equal to EQ into 2A sin theta. But Q into 2A is equal to P. Therefore, τ is equal to EP sin theta. This is the expression for torque acting on the dipole. Vector form of torque acting on electric dipole moment. Vector τ is equal to vector P into vector E. Note: we have τ is equal to EP sin theta. 1. If theta is equal to 0 degree, then sin theta is equal to 0. Therefore, τ is equal to 0. That is, torque acting on electric dipole is minimum. 2. If theta is equal to 90 degree, then sin theta is equal to 1. Therefore, τ is equal to EP. That is, torque acting on electric dipole is maximum. 3. If theta is equal to 180 degree, then sin theta is equal to 0. Therefore, τ is equal to 0. That is, torque acting on electric dipole is minimum. 4. SI unit of torque is Newton meter or Nm. 5. Torque is vector quantity. 6. Its direction is perpendicular to the plane containing P and E. 7. The direction of torque is given by right-handed screw and cork rule. Next, continuous charge distribution. 1. Linear charge density, denoted by lambda. It is defined as the charge per unit length. That is, linear charge density is equal to charge by length. That is, lambda is equal to delta Q by delta L. SI unit is coulomb per meter. 2. Surface charge density, denoted by sigma. It is defined as the charge per unit area. Surface charge density is equal to charge by area. That is, sigma is equal to delta Q by delta S. SI unit is coulomb per square meter. 3. Volume charge density, denoted by ρ. It is defined as the charge per unit volume. Volume charge density is equal to charge by volume. That is, ρ is equal to delta Q by delta V. SI unit is coulomb per meter cube. Next, mention the expression for electric field due to continuous charge. Distribution. Electric field due to delta Q charge present in small volume element delta V is delta E is equal to 1 by 4 pi epsilon naught into delta Q by R square. Equation 1. But ρ is equal to delta Q by delta V. Therefore, delta Q is equal to ρ delta V. Equation 1 becomes delta E is equal to 1 by 4 pi epsilon naught into ρ delta V by R square. Electric field due to entire volume V is E is equal to summation of delta E. That is, E is equal to 1 by 4 pi epsilon naught summation of ρ delta V by R square. This is the expression for electric field due to continuous charge distribution. Next, GAUSS'S law. Statement. The total electric flux through the closed surface in a free space is equal to 1 by epsilon naught times the net charge enclosed by the surface. That is, total electric flux is equal to Q by epsilon naught, where epsilon naught is absolute permittivity of free space. Note: Gaussian surface. It is an imaginary closed surface containing the charged body chosen for application of GAUSS'S law. Consider the Gaussian surface containing the charges as shown in figure. From GAUSS'S law, electric flux phi E is equal to Q1 plus Q2 plus Q3 by epsilon naught is equal to Q by epsilon naught, where Q is equal to Q1 plus Q2 plus Q3. Proof of GAUSS'S law. Consider an isolated positive point charge Q at O. Imagine a sphere of radius r with center O, as shown in the figure. The magnitude of electric field E is same at every point on the surface of the sphere, and it is directed radially outwards. Let delta S be the small area element on the surface of the sphere. S be the area of the sphere. Q be the charge enclosed by a sphere. Therefore, electric field at the surface is E is equal to 1 by 4 pi epsilon naught into Q by R square. Mark it as equation number 1. Therefore, Small electric flux flows through data S is given by delta phi is equal to E cos theta, delta S. If theta is equal to 0 degree, then cos theta is equal to 1. That is, delta phi is equal to E into delta S. Mark it as equation number 2. Now, flux through the spherical Gaussian surface of area S is given by phi is equal to summation OD delta phi. That is equal to phi is equal to summation of E delta S. The equation can be written as phi is equal to E into summation of delta S. Mark it as equation number 3. Now, substitute equation 1 in 3. We get phi is equal to 1 by 4 pi epsilon naught into Q by R square into summation of delta S. But summation of delta S is equal to 4 pi R square. Therefore, phi is equal to 1 by 4 pi epsilon naught into Q by R square into 4 pi R square. On cancelling the terms, 4 pi R square from numerator and denominator, we get final equation, that is, phi is equal to Q by epsilon naught. This is called Gauss law. Significance of Gauss law. 1. Gauss law is true for any closed surface, no matter what its shape or size. 2. According to Gauss law, phi is equal to Q by epsilon naught. Here Q is the sum of all the charges enclosed by the surface. 3. The surface that we choose for the application of Gauss law is called Gaussian surface. 4. Gauss law is based on inverse square dependence on distance contained in Coulomb's law. 5. Gauss's law is applicable for both the stationary and moving charges. 6. Gauss's law is based on inverse square law. This ends today's class. In next class video, we see the applications of Gauss's law. So don't forget to subscribe the channel for more updates.